Interference is redistribution of energy on superposition of two waves. At certain places, we find that intensity has increased, and whereas at other places in the vicinity, we locate the positions where the intensity overall decreases. So, it is a process of redistribution of energy, and the two types of interferences are like two sides of a coin. One is constructive, the other is destructive interference. I am going to elaborate here. In this page, in this episode, we will discuss regarding constructive interference. When two waves will meet in the same phase, the resultant amplitude will increase, and this would be known as constructive interference. If they are in the same phase, it means there is no phase difference. Phase difference 0 means they are in the same phase. And you know, when you complete one round, means 360-degree you have just rotated or revolved, then you again come back to the same point. That means the phase difference of 2 pi radian, or you might say 360 degrees, no phase difference, that is same phase. So, that way you could say if the phase difference is going to be integral even multiple of pi, it is going to be constructive interference. We also know that phase difference is given by this relation 2 pi by lambda delta x. So, if you put here 2 m pi that we got finally for constructive interference, by putting this value you will find this delta x comes out to be equal to m lambda only. M lambda means integral multiple of wavelength. M can possibly have the values 0, 1, 2, integral values. So, if the path difference is 0, lambda, 2 lambda, 3 lambda, then also you are going to have the constructive interference. That way you could say if the phase difference is even pi and the path difference is integral multiple of lambda, in both the cases are in fact equivalent. In both the cases we have constructive interference. Now, if phi is 0, cos phi is going to be 1, and likewise for all even pi values of phi, you are going to have cos phi equal to 1. By using the relation y1 plus y2, that is equal to y, if we calculate, finally we will find the formula for amplitude like this. Using phasor diagram, the final result that we find for resultant amplitude is this one. If you put this, one more thing, you see intensity is directly proportional to square of the amplitude. If you want to write this relation in terms of intensity, it is going to be I1 plus I2 plus 2 root I1 I2 cos phi. So, for amplitude and for intensity both you are having the relation. If you put cos phi equal to 1, you are going to have a square or a equal to a1 plus a2 square, simply because you see if you put here 1, you are going to have this k1 plus a2 whole square, and likewise you are going to have this I equal to root I1 plus root I2 whole square. This is the value of A maximum. When you will put here 1, it will become A maximum, but A you can have A1 plus A2 whole square, this thing, A1 plus A2 whole square, by putting this equal to 1. Similarly, I maximum you are going to have root I1 plus I2 whole square, I maximum. Then this is for constructive interference. In constructive interference, the energy will be concentrated, or you could say that resultant intensity increases over there, that becomes more significant. In fact, the energy has migrated from surrounding points to this place, and here the energy concentration has increased. And remaining things I have told you, phase difference should be even pi to m pi. Path difference, this is point to remember, this is rather to be underlined, it should be focused. Here m will have possibly the values starting from 0, integral values. This is the key point to be noted for constructive interference.